Biochar inoculation. This is one of the important methods of value addition to biochar. There is lots of confusion among the biochar users how to bring up the nutrients into the biochar. So biochar inoculation is one such method. Here I am explaining in detail some of the methods of biochar inoculation. Why there is a need for biochar inoculation? This is to harness the synergetic interactions between biochar and various inoculants, and farmers can improve soil health, enhance nutrient cycling, reduce environmental impacts, and promote sustainable agricultural practices. Inoculation in microbiology is the process of introducing microbes into a media so that it reproduces there. Organic matter inoculation through charging method. Biochar can be combined with organic materials such as compost, manure or farmyard manure or green waste to create a nutrient-rich inoculant. The organic matter provides essential nutrients, beneficial microbes and organic carbon to the soil, while biochar enhances nutrient retention, water holding capacity and microbial activity. This combination promotes soil fertility, improves soil structure and stimulates microbial activity, leading to enhanced plant growth and productivity. Microbial inoculation. Biochar can serve as a carrier for beneficial microorganisms such as plant growth promoting rhizobacteria, PGPR, mycorrhizal fungi, nitrogen fixing bacteria and other beneficial microbes. These microorganisms can be inoculated into biochar surfaces or incorporated into biochar pores to enhance their survival and delivery to the soil. Once applied to the soil, the biochar provides a stable habitat for the microorganisms, facilitating their colonization and establishment in the rhizosphere. This symbiotic relationship between biochar and the beneficial microorganisms promotes nutrient cycling, improves soil health, and enhances plant nutrient uptake and growth. Apart from microbial inoculation, nutrient inoculation can also be done. Biochar can be impregnated or coated with nutrient-rich solutions containing essential plant nutrients such as nitrogen, phosphorus, potassium, calcium, magnesium and other micronutrients. These nutrient-loaded biochar products serve as slow-release fertilizers. These nutrient-loaded biochar products serve as slow-release fertilizers, gradually releasing nutrients into the soil over time. The porous structure of biochar enhances nutrient retention and reduces nutrient leaching, ensuring a more efficient use of fertilizers and minimizing environmental impacts. Another concept that we get to discuss here is the nano fertilizers concept. So here biochar acts as that media which retains these nutrients like zeolite or other materials which are used in the process. And within this nutrient inoculation, say we want to inoculate biochar with nitrogen. Chemicals such as urea, ammonium sulfate or ammonium nitrate can be added to biochar to increase its nitrogen content. Nitrogen is a crucial nutrient for plant growth, and supplementing biochar with nitrogen sources can enhance its fertilization capabilities, especially in nitrogen deficient soils. Phosphorus sources. Phosphorus is another essential nutrient required for plant growth and development. Phosphorus containing compounds like phosphate rock or rock phosphate or triple superphosphate can be incorporated into biochar to improve soil phosphorus availability and enhance plant productivity. Potassium plays a vital role in plant nutrient uptake, especially in osmoregulation and stress tolerance. Potassium containing fertilizers such as potassium chloride or potassium sulfate can be mixed with biochar to enhance its potassium content and promote soil fertility. Micronutrients. Micronutrients play a most important part in the plant's growth. Here biochar can be enriched with micronutrients such as zinc, iron, manganese, copper and boron. To address specific nutrient deficiencies in the soil, micronutrient enriched biochar formulations are particularly beneficial for soils with poor micronutrient availability or imbalances. Liming agents. Agricultural lime, calcium carbonate or dolomitic lime, calcium magnesium carbonate can be added to biochar to adjust soil pH and reduce soil acidity. Liming agents help neutralize soil acidity, improve nutrient availability and create a more favorable environment for plant growth. This is for the acidic soils alone. For alkaline soils, we need to add other materials. To reduce the pH of the soil, especially in the saline or alkaline soils, one common method for reducing soil pH is by incorporating gypsum, also known as calcium sulfate, into the soil along with the biochar. For the alkaline soils, one could add the materials like gypsum, elemental sulfur, ammonium sulfate or ammonium nitrate, or including organic materials such as humic acid, compost or mulch, which also release organic acids. In the process, all these things would lower the pH of the soils. Biochar by nature, it is slightly alkaline, so always it is recommended to add on these kind of materials as suggested here, especially when we are applying to alkaline or saline soils. Biochar can be combined with soil chemical amendments such as lime, gypsum, rock phosphate and other mineral amendments to create customized soil inoculants. These biochar based inoculants improve the effectiveness and stability of chemical amendments, reduce nutrient loss through leaching and runoff, and enhance soil pH, nutrient availability, and cation exchange capacity. By incorporating biochar into chemical soil amendments, farmers can optimize nutrient management, reduce fertilizer inputs, and improve soil fertility and productivity in a sustainable manner. This chemical amendments is an option to the farmers, it is not a must. But the farmers who are already using them, along with biochar, if they use them, the efficiency of the application would improve and the benefits of these materials would reach the plant. Otherwise, most often these materials they end up in the water bodies or get embedded within the soils, and in the long run are leading to pollution of the environment also. One has a choice to go with organic inoculants or natural minerals that can be inoculated with biochar, or the chemicals that are specially made which can also be inoculated. So there are various methods and choices with biochar. So it depends on the choice of the user. Other soil amendments such as gypsum, calcium sulfate, humic substances or zeolites, coco peat, rock dust, sand can be combined with biochar to address specific soil constraints, improve soil structure and optimize nutrient cycling processes. So there are hundreds of different materials which are geographically and which are feasible to adopt or available. So in every challenge, the soil conditions, one should always look at what are the various other materials that are available which can be inoculated with biochar or which can be applied along with the biochar. So this adds lots of value, and we can also reduce the cost of the applied materials overall. pH adjusters. In biochar, pH adjusters can play a crucial role in modifying soil pH to create an optimal environment for plant growth. Here are some common pH adjusters used in biochar. Phosphoric acid. Phosphoric acid can be used as a pH adjuster to lower soil pH and provide phosphorus to plants simultaneously. When applied to biochar, phosphoric acid gradually releases hydrogen ions, leading to soil acidification, while also supplying phosphorus, an essential nutrient for plant growth and development. Organic acids. Organic acids such as citric acid or humic acids can be added to biochar to adjust soil pH and enhance nutrient availability. These acids promote the chelation of cations, making them more accessible to plants. Additionally, organic acids can stimulate microbial activity in the soil, contributing to overall soil health and fertility.